Hi guys, so this video I'm going to talk about modern TypeScript from first principles. Okay, so this will be a ground up guide to building forward looking mobile friendly websites with TypeScript, modern CSS and modern HTML written for evergreen browsers only. So it's been less than a month since TypeScript 7.0 has released, and let's talk about what TypeScript actually is, right? So before we configure anything, it's worth being precise about what TypeScript is, because most of its practical rules follow directly from one fact. And that fact is that TypeScript is JavaScript plus static type checking layer plus a static type checking layer that Microsoft's compiler deletes before your code ever runs. That's it. That's the whole idea. Every valid piece of modern JavaScript is, with a handful of edge case exceptions, also valid TypeScript. TypeScript is a strict syntactic superset, right? What TypeScript adds is annotations, extra syntax like colon string or interface user squiggly braces that exist purely so a compiler or your text editor can check before a single line executes that the values flowing through your program are shaped the way your code expects. The single most important consequence of this is that types have zero runtime cost and zero runtime existence. Compiling a .ts file to a .js file isn't a transformation of your logic. It is a deletion of your annotations. For example, open the TypeScript playground and write function double parentheses n colon number squiggly return n times 2 n squiggly, right? And look at the JavaScript output. Function double n squiggly return n times 2 semicolon n squiggly, right? Character for character, the same function with the type stripped out. Nothing was added. That's why you'll sometimes hear TypeScript's relationship to JavaScript is summarized as becoming JavaScript via the delete key rather than via a compilation step in the traditional sense. So why does it matter? Because types are erased, TypeScript can never make your program correct by itself. It can only refuse to compile programs it can prove are shaped wrong. A type error or a compile error and a bug at runtime are different categories of problem, and the rest of this guide keeps circling back at this distinction. This is worth repeating because types are erased. TypeScript can never make your program correct by itself. It can only refuse to compile programs it can prove are shaped wrong. A type error at compile time and a bug at runtime are different categories of problem, and the rest of this guide keeps circling back to this distinction. TypeScript also uses structural typing, sometimes called duck typing, done rigorously, not the nominal typing you may know from Java or C#. In a nominal system, a value belongs to a type because it was declared with that type's name. In TypeScript, a value belongs to a type because its shape matches regardless of what, if anything, was declared, right? So duck typing, if you didn't know, comes from the fact that there's a famous quote: if it walks like a duck and quacks like a duck, it is a duck, right? So structural typing.ts, let's say there's an interface point with x number, y number, right? And there's a function distance from origin p colon point, which returns a number. and you return math dot square root p dot x times p dot x plus p dot y times p dot y. Now that's the distance. Now we never have to declare a point when we use it. For example, const x equals squiggly x, const location equals squiggly x colon 3 y colon 4 label cafe, right? So the label cafe was not an interface point, right? So strictly speaking, it's not a point. But when we use it from distance from origin, this new location variable that we just created with x colon 3 y colon 4 and label colon cafe, it fits in the interface point, which only has x colon number and y colon number, right? It doesn't have the label cafe. So extra properties don't disqualify this object from belonging to this interface. So nothing declared location to be a point, and TypeScript doesn't care. It checked the shape at the call site and found x of type number and y of type number present, which is all distance from origin actually asked for. This single idea that types describe shapes, not labels, explains a surprising amount of TypeScript's behavior, including why interfaces quote-unquote merge, why object literals get slightly stricter quote-unquote extra property checks that regular variables don't, and why two unrelated interfaces with identical members are fully interchangeable. So let's say these three things again. One, why interfaces merge. Okay, why interfaces merge. And two, why object literals get slightly stricter access property checks that literal variables don't, right? So object literals get slightly stricter access property checks. And two unrelated interfaces with identical members are fully interchangeable. So once again, TypeScript is JavaScript with syntax for types. So let's talk about the history. A short and eventful history of TypeScript. TypeScript is older than most of the frameworks built on top of it, but the pace of change has never been higher than right now. October 2012 is when TypeScript 0.8 got its first public release, released by Microsoft after 2 years of internal development led by C# architect Anders Hellberg. In November 2022, about 10 years later, TypeScript 4.9 got the satisfies operator. The satisfies operator is a new way to validate a value against a type without widening or discarding its inferred shape. In March 2023, TypeScript 5.0 was introduced, which has decorators and const type parameters. Standards track decorators were shipped along with const type parameters for narrower generic inference. So somewhere between 2024 and 2025, Node.js learns to run .ts files directly. Type stripping support landed behind flags, and then it got unflagged, and then it was on by default. In March 23, 2026, TypeScript 6.0 was introduced, which was the last JavaScript-based release. A deliberate bridge release, strict mode, ESM, and a modern target became the default, and a batch of legacy options were deprecated ahead of 7.0. And recently, July 8, 2026, TypeScript 7.0, a native Go compiler, went GA, which means it became generally available. The compiler and language service were rewritten from scratch in Go, same type checking rules, usually 8 to 12 times faster. That's right.